For over 2 years now, I've been saying that Nvidia would be launching their own PCs with ARM-based SoCs, aiming to disrupt the PC segment traditionally dominated by Intel and AMD on the x86 side and Apple on the ARM side, with Qualcomm now a part of their group also. A couple of days ago at GTC, Nvidia announced what I think is the start of Nvidia's plan to revolutionize PCs, but not all is what it seems. While the DGX Spark is being marketed as an AI developer box, I think the potential for this mini PC lies somewhere else entirely. In fact, I think it might be pretty mediocre as a PC for AI developers. URCDkeys.com are having a March Super Sale, giving you access to Windows 11 Pro keys and Office keys for a super affordable price. If you buy a Windows key directly from Microsoft, you'll pay around $150 depending on your region, and that's for a home edition license. But if you buy an OEM key from URCDkeys.com, you will only have to pay $21.86 at the time of making this video, if you use my coupon code C25, and that's for Windows 11 Pro. These keys work globally and you'll get them within minutes. You can pay with a credit card or with PayPal. After purchasing, go to your purchased orders page and copy the key, and then on your Windows 11 install, type in the search activate and enter your key in the appropriate field and click activate. And that's it, your Windows is activated and you can change your wallpaper and customize Windows and all that. You can also get Office 2021 Professional Plus at less than half the price with my coupon code C25. Check the links in the video description for your cheap OEM Windows keys today. Most of Jensen's keynote at GTC was immensely boring, but there were a few announcements that I found interesting and relevant for our niche as PC enthusiasts. I'll focus today on the two products that I think will eventually have the most significant impact within the PC space, and I'll leave the rest for another video. I first started talking about Nvidia entering the PC segment with the desktop ARM-based SoC in 2022, more than 2 years ago now. Tech moves fast, and since then, Nvidia's focus has shifted heavily towards AI, as you all know. And because of that, I think Nvidia's entry into the desktop space resulted in a product that has ended up adapting to market demand in that field. I get the feeling that the Spark wasn't what Nvidia had originally in mind, and I'll explain why in a second. The two products in question are the DGX Spark mini PC and the DGX Station, which is a more traditional PC tower. The DGX Station already existed. Nvidia introduced the original one several years ago now for the professional market, especially for data science, but this new version is much more akin to a traditional PC with M.2 slots and PCIe slots and whatnot, and of course it now features the GB300 chip, or super chip as Nvidia likes to call it. The motherboard for this station looks insane. However, I want to focus on the DGX Spark, as that's the most consumer focused of the two. I mean, don't get me wrong, this is still aimed at developers, and it's still a niche product, but it's encroaching on the territory of Apple's Mac Mini and AMD-based mini PCs like the AI X1 that I reviewed a few days here on the channel. If you saw my review of the minis from AI X1 Pro, I said in that video that I was expecting to see announcements from both Nvidia and their partners of mini PCs with a similar ethos at GTC. And indeed, it wasn't just Nvidia announcing the Spark mini PC. The Spark is a platform that Nvidia partners can adapt and sell themselves. And there are already two models announced, one from Asus and one from Dell, which have the exact same board, just different form factors. Looking at the Spark on the surface level, its two unique selling points are the large pool of unified shared memory to run large AI models, and more importantly, the fact that the Spark is a miniaturized version of the DGX pod, at least in theory. The reason that's so vital vital is that Nvidia positioned the Spark as a product that allows AI devs to work on a platform that derives from what they will find in the cloud. So the idea is that if you develop code for the Spark locally, Nvidia guarantees that it will work once deployed on a larger scale on DGX-based servers. That means you can transition from a local, small-scale development environment to a production environment seamlessly. The DGX Spark is available in two variants. One is $3,000 and the other is $4,000. The difference between the two is that the $3,000 version has a 1TB of storage and the $4,000 has 4TB of storage. As with the AI X1 Pro that I reviewed, storage is nowhere near as important as RAM in these sorts of machines. So a byproduct of the growing need for computation that is specialized is that we're seeing a shift to highly goal-focused specs, in this case foregoing storage in favor of RAM capacity. But it's when you look below the surface that things get a bit confusing. Looking at the board itself, we can see here the GB10 SoC built in partnership with MediaTek, and around it we find LPDDR5X RAM modules, 8 of them, for a shared pool of 128GB of memory. Notice that the SoC has two chips in package, a GPU and a CPU, connected through Nvidia's proprietary interconnect called C2C, basically NVLink, which Nvidia claims is around 5 times faster than PCIe Express. The two chips have a shared memory controller. The CPU is a custom 20-core ARM-based chip, and the GPU is a 5000 series Blackwell chip, so it supports things like DLSS and RTX. So beyond this being an AI developer box, this is an extremely capable machine also for game development and for 3D modeling and rendering. And that's where I think we see that Nvidia kinda got lost between two minds when developing this. In addition to these basic specs, the Spark ships with Linux, more specifically a custom version of Ubuntu. So even though the SoC is built on the ARM ISA, therefore this isn't an x86 machine, if we look at what Valve has done with Linux, it seems perfectly plausible that this device could be used in game development for Linux-based ARM PCs, and with high-end graphics included from the get-go. Remember, this features a Blackwell GPU. I believe that in the coming months we will see investment from cloud companies and also from venture capital in AI hardware stagnating, and with robot AI assistants and companions still in their infancy, so to speak, I think Nvidia's strategy for the Spark is to bridge all of their verticals. You see, on the Apple camp, when it comes to professionals, you can find graphic designers or web designers and programmers of various kinds. People use Apple computers in those fields because they've been tuned to offer a great ecosystem for visual creators. But computationally, those workloads are not that demanding. A graphic designer can work off of a MacBook connected to a large monitor and get all the performance they need. Nvidia, on the other hand, with the Spark, is targeting a new kind of creator/developer, where the output that those professionals are seeking is much more sophisticated, with a much tighter integration between software and hardware, and crucially requiring a lot more computation. Nvidia is projecting that as AI becomes more pervasive and seeps into several different professional fields, people will be wanting more than a mini PC or laptop that is great at the Adobe suite of apps or Logic or the Apple developer ecosystem. So these same people will want to enhance those basic applications with new AI capabilities that take their work to a new level, giving them a competitive advantage over others. In that sense, the DGX Spark is a foundational product. It's aiming to create a whole new kind of professional, one that takes advantage of the synergy between AI, LLMs, data science, and 3D computation, which all congregate in a single small desktop mini PC that is tied to Nvidia's numerous SDKs. Nvidia covers everything from advanced graphics with their GPU stack, automotive with Drive, 3D design and game development with Omniverse, computer lithography with QLitho, a name that I'm sure Spanish-speaking viewers will appreciate, enterprise solutions for data analytics, robotics, healthcare, networking, and more. The DGX Spark opens the door to integrating all of these Nvidia verticals into a professional's workflow as needed. Then, once those professionals start evangelizing the platform and expanding on the platform with their own creations, Nvidia can then introduce consumer-focused products that are streamlined versions of the Spark in mini PC form factors, but also as laptops and desktop towers. When you think about it, this strategy is not too different from the trajectory that Apple took a few decades ago. Back in the early days when Steve Jobs returned to the company, Apple computers were used almost exclusively by professionals, so graphics designers, web designers, that sort of crowd. And only after that foundation was established did Apple fully transition into the mainstream. That was a very different strategy than Apple's initial strategy back in the 80s, when the idea was to compete head-on with IBM PCs. Similarly, I think Nvidia is trying to position the Spark as a foundational product that will feed off of the Nvidia ecosystem based around CUDA, but also the collaborative 3D tools that they now offer through Omniverse. And as I mentioned earlier, it comes out of the box with support for things like RTX and DLSS. So even though on the surface Nvidia is marketing this as an AI development box, beneath the surface I think we're seeing here a very sophisticated strategy from Nvidia that takes inspiration from Apple in a lot of ways. However, as far as the execution goes, I think Nvidia made a few strange decisions here. One of the things that will immediately stand out to you looking at the Spark board is the gigantic enterprise-grade Connect X7 dual-port Ethernet NICs, which according to Nvidia are there so that users can connect two DGX Sparks together. This networking solution is ridiculously expensive. It's like $1,500 for one of these NICs. So why would Nvidia include such an expensive component in a foundational device? Well, because the fundamental problem with this machine is the limited bandwidth it offers for what it is being marketed as. If you look at a platform like Nvidia's MGX, so the big boy DGX racks, you get coherent memory separately for the CPU and GPU, with LPDDR5X for the Grace CPU and HBM3 for the GPU, with 900 GB per second connectivity between the CPU and GPU. But with the Spark, you only get LPDDR5X, so you are only getting the second tier memory of the MGX platform. In other words, if you look at the GH200 Grace Hopper board, you have three tiers of memory, where the HBM works essentially as a large pool of high bandwidth cache, which is used for the weights and layers that need to be accessed more frequently. So for critical processing, you get the maximum possible performance. The next tier of memory in the GH200, that low power DDR5, serves as a buffer of higher capacity, but that is much slower. So what you do with the second tier of memory is you preload weights. So basically you're implementing a strategy of latency hiding. And then the last tier of memory are of course the NVMe drives, so your storage, which gives you persistent memory to have your complete model accessible. So with the MGX system, developers can strategize and manage memory in such a way that the system can predict what weights will be used and load up these memory tiers accordingly for much faster performance and efficiency. But that is not an option with the DGX Spark. Nvidia is claiming that the Spark is a derivative of that MGX rack model, but the reality is that you don't get this memory tier paradigm. All you get is LPDDR5 and the NVMe, so bandwidth becomes a massive bottleneck in a system like this. If you use ChatGPT or Perplexity AI, you might have noticed that most of the operations are decoding, meaning accessing weights at each step of the token generation. Most of these AI services will even show you the process happening in real time. So feed-forward operations are crucial in inference, and not so much the actual computation capabilities, the flops. For the sort of workload that Nvidia is marketing here, what matters is how fast you can load weights from RAM, especially in the sort of development environment where these mini PCs will be used. All of that to say that the Spark is kinda not great for AI, considering all the other options out there, including from Nvidia. And that brings us back to these Connect X7 network adapters that make this mini PC from Nvidia so expensive. Nvidia included these NICs to try and mitigate this bandwidth problem. By connecting multiple DGX Spark boxes together, you can implement a distributed inference strategy, and in that sense compensate for the memory limitations in each individual box, seeing as you get tensor parallelization and a large pool of aggregate cache. I won't go too deep into that, but it seems that Nvidia's solution to the bandwidth limitations of the Spark, using these network adapters for multiple boxes connected together, end up making this whole solution a lot more expensive than even Nvidia's own cloud offerings. And crucially, this ends up being more expensive and worse than using a Mac Mini cluster. Nvidia's DGX Spark is both not exceptional at computation, and it's pretty bad when it comes to bandwidth, so the Spark has a bit of an identity crisis. Those using Apple's mini PCs like the Mac Mini already have a good cost-effective way of doing unified memory. That's why Mac Mini clusters have been so popular in this niche, so you'd have to specifically need CUDA to want something like the Spark for the investment to be worth it. But if that's the case, then Nvidia's other offerings are much better value, like renting time with an actual DGX pod. And all that brings me to the initial point that I made, and to the synergy between Nvidia's products and how the Spark might make sense there. Despite Nvidia's surface-level marketing, I think this is not as much a mini PC for AI developers as Nvidia positioned it during GTC. I think the Spark is looking to be a foundational product for a whole new type of developer, one that makes use of several of Nvidia's verticals in addition to AI development. I mentioned game development and 3D work as that's what comes to mind as a perfect fit, but Nvidia's offerings allow for multiple use cases where the Spark could make sense. Whether Nvidia can create this new kind of developer that relies on their full stack is anyone's guess. Another example that comes to mind are edge computing businesses, or basically anything that needs a lot of inference processing locally, like a factory with automated manufacturing or image recognition in surveillance. Now, when it comes to the commercial side, unlike Apple, who sells and ships their own products, to help with both distribution and availability, Nvidia has partnered with Asus, Lenovo, HP, and Dell to sell mini PCs based on the same DGX Spark board, but with their own case designs and different cooling solutions. As I mentioned earlier, Asus has already announced theirs, which is called the Ascent GX10, and which is priced at $3,000 for the 1TB model, the same amount that Nvidia charges. And Dell have also announced theirs, the Dell Pro Max, and these will release in the summer. Nvidia knows that the sort of businesses that would want this kind of device typically already rely on system integrators for deployment, so these partnerships make perfect sense, and Nvidia doesn't have the distribution network that Apple has yet. So if the Spark is a foundational product, what comes next? I think that regardless of the Spark being mega successful, I think it's inevitable that not before long we will see a streamlined version of the Spark that is entirely consumer focused, a more generalized box, computationally speaking, that will compete directly with the Mac Mini and the Mac Studio. In addition to a consumer focused mini PC, I think it's a matter of time until we will see a line of laptops that will compete with the MacBook and MacBook Air from Apple, just like we see Nvidia offering reference models of their GPUs, but then there are also partner models from Asus, MSI, Gigabyte, etc. I believe we will see a similar strategy being implemented in the coming months, where Nvidia's partners will start offering consumer-focused products based on Nvidia ARM SoCs. The question is what operating system Nvidia will be using. The Spark uses Linux, and that could be an indicator. We'll either see a custom operating system similar to what Valve did based on Linux, and that would be a massive threat to Microsoft, or we might see Nvidia adopt Windows for ARM. With two giants like Qualcomm and Nvidia making ARM-based SoCs, I think Intel and AMD should really be contemplating their options. I've done videos in the past where I discussed this, and so far there have been no moves from those two companies to try and prepare for a much larger shift to ARM. The Spark is laying the foundation, enticing developers to adopt Nvidia's full stack before consumer-focused, sophisticated applications are ready to be used, with a new wave of devices that will look fairly different than today's PCs. Machines that will be more specialized, and unfortunately also more proprietary. Before that happens, we're seeing AMD introducing a bunch of devices through their partners, like the Minis Forum mini PC that I just reviewed, that let you run the AI application applications that currently exist locally, and I expect to see a lot of those in the coming months also. As far as the other things announced at GTC by Nvidia, there were a few that I think are very interesting and point to the future generations of Nvidia gaming focused products coming in the next couple of years, but I'll leave that for a future video. Be sure to subscribe so you don't miss that. This video was made possible by my awesome patrons. Consider becoming a member of my Patreon for just a couple dollars per month and get exclusive content and exclusive access to the Cortex Discord server. Thanks for watching, and until the next one.